Screen?
Yep.
Cool. Today I'm going to go over the security profile KEP, which was drafted quite long ago. And this still sits in the Kubernetes community repo. The KEP currently is closed. So probably in future, as the KPI currently moved to a different repo, so probably in future, I will have a chance to resubmit a new KEP, mostly based on same content, but maybe with a clear scope. So first about the security profile, why we are thinking about this feature in Kubernetes for a few reasons, because today configuring a Kubernetes cluster is so complicated. There's a lot of concepts like policy objects like RBAC, policy policy, network policy, kind of stuff, and also requires the class admin have an in-depth knowledge about security and relevant domain area knowledges, and plus the complexity of setting up the correct command line flags to make sure there's no potential security risk. There's actually a lot of work to do. And without a common solution, people are also building like in-house solutions with different kind of tools. It's really difficult to share in the community if people are building things in different ways and with different aspects from the user scenarios. So the proposal trying to provide a well-defined common place for people to specify a best practice to set up a Kubernetes cluster which is secure or even meet further restriction requirements potentially can be used to secure a cluster for a multi-tenancy scenario. So the proposal basically defines a syntax. For example, it can be presented in YAML or something, and as a set of rules, which includes 3 parts. The first is about the bootstrapping configuration. So it defines a bunch of rules all about the command line flags of all the Kubernetes control plane, like API server, control manager, scheduler, and all other kinds, including etcd kind of stuff. And possibly other stuff like file permissions of the certificated files, key files, which must be secure. And these are basically rules, not like something predefined values for command line flags that can be directly used when you create cluster. So it works basically by first you specify the Kubernetes command line flags by some tools like kubeadm, and you can use security profile these rules to validate if these command line flags comply to this with this security requirements. And the second part is all the cluster scoped policy objects, including like policy, security policy, and all the RBAC rules and other stuff. So these are mostly very simple Kubernetes resources that can be directly created into a cluster when the cluster is up and running. And no additional mechanism required for that. And the third part is about namespace scope policy objects, like network policy, and possibly like something like a resource quota or kind of things. This is part is special because you can never create these policies without namespace. So we need some mechanism when a namespace is created, these policies gets automatically created inside a new namespace. So with all these 3 parts, we can define a security profile like in this example. So you can think that as a regular Kubernetes manifest file. So first it defines the security policy, and then a namespace template, which I will mention that later. It is used to populate the policy objects into namespaces. And then define a CRD, which called security profile. And within this CRD, it references all three components. So in the spec, it first comes with bootstrapping rules to define some requirements on the command flag. Then it defines the runtime rules to reference the namespace template, which will create policies into namespaces. So with all this information in one manifest file, you can simply use the kubectl apply to import this file into a cluster. And then with a controller running inside the cluster, it can help enforce the policies in a namespace when a namespace gets created. So let's quickly skip into the proposed security profiles. So in the KEP, I proposed two security profiles with different levels of requirements. The first is default, which is very permissive profile, mostly focus on the command line flags, try to avoid some very basic mistakes like turning on basic auth, so kind of stuff. So it has a very long list of bootstrapping rules to require turning off some insecure options like anonymous auth, basic auth, and ABAC kind of things. It has mostly no rules defined for the namespace scope policies. And the second one is SaaS multitenancy, which is more restricted than the default one. So it will use the policy security policy, and by default, the pod created in namespace won't have, cannot be privileged pods, and it will disable the privilege escalation and also may not allow root permissions. And it will also limit the volume types that can be used in a pod. And within this security profile, it also includes a network policy by default to block all the ingress and egress. So you have to explicitly whitelist the traffic with their own network policy. That basically provides a very secure default for the cluster. And these are basically two samples of security profile. And the idea is if the community can help define or refine these two samples and define more security profiles according to the common use cases that people are using Kubernetes day to day. So that definitely needs help from the community to make these things perfect. So let's see a few use cases. So basically with security profile, we want to achieve a very easy user experience. Like if you want to create a Kubernetes cluster, you can just type a single command. So here, the Cloud CI is just an example. You can think about something like kubeadm or something else. When you create a cluster, you simply specify the name of security profile. It will take care of setting up everything automatically. And once the cluster is ready, all the policy objects has been set up, and you are ready to use this cluster in a secure way. And also, with a restricted security profile, when you create a new namespace, the namespace policy policy object gets automatically created into the new namespace. So let's go to the implementation, a little details of the implementation. So just as I mentioned in the example, a security profile is basically a set of manifest files. They are standard Kubernetes manifest files. They define a bunch of cluster scope policy objects and a custom resource called security profile, which includes bootstrapping rules and also a reference to a namespace template, which is another custom resource. And for bootstrapping rules, it defines just rules, not the actual value of each of command line flags. So for example, you can define rules, say the anonymous auth flag cannot be specified, or the admission control, the authorizer ABAC cannot be present in command line flags. So these are all kinds of rules. So you can write some tool to check the actual command line flags according to the rules. And the runtime rules is mostly about the policy objects into a namespace. So we'll have a custom resource called namespace template, which defines the policy objects into a namespace. So we can, I can quickly go back to the example with this namespace template. So in the spec, let's skip this namespace selector right now because these things are still changing. I don't think the namespace selector is still applicable according to today. So in the spec, there's a templates section. So it's basically an array of a regular Kubernetes resources like role bindings, all kinds of stuff. You can basically define any Kubernetes resource in this template. And when namespace gets created, the resource defined in these templates are created into the namespace. So with that, you can easily define the role bindings, and also network policies and other objects. So let's go to some other details. So in a cluster, you can define multiple security profiles. And at a time, there's only one security profile is effective. So by how to achieve that is we introducing a security profile selector, CRD, which has only one field called enforce. And the value specify which security profile is currently being enforced, or say effective. And we can switch security profiles by updating this selector. And when a security profile gets switched, the newly created namespace will be affected. All existing namespace won't change. They will contain the policy objects created from old security profile. So there's a few advanced features like enforcement status, which will be a little more complicated to implement. So the idea is we can try to add a status session into a security profile, which reflects the enforcement status of each rule. For example, some rules take a while to get enforced. For example, the namespace template. When the namespace gets created, it takes maybe a few milliseconds to seconds to get all these policies created. So when you inspect the security profile, you can try to find out the status, whether a rule has been enforced or still in progress. Okay, so I'm going to jump to the namespace population, which is basically the most important part of the security profile regarding this the enforcement policy, because this is actually very complicated. So I created a separate KEP called namespace population. So this is namespace population KEP. And the motivation is in the scenario introduced by the security profile, we need some mechanism when a namespace gets created, the policy objects gets automatically created into the newly created namespace. And this is really helpful when we allow users to do a self-service namespace creation. So thinking about alternative ways is basically when I want to create a namespace, I don't have permission to do that, and I have to explicitly ask class admin to do that, or through some different service APIs, all kinds of things. If we go down that path, it's actually much easier, and because the different service API or the class admin can do everything. After creating namespace, they can basically have the opportunity to create policy objects and everything, make the namespace ready, and then notify me, okay, you can use the namespace. Then everything gets set up. While in the case, if I want to create my namespace, I want to be quick. So I just use Kubernetes to create namespace and provide my namespace name. And I want the namespace being ready with all of the policy objects when it's ready. So that's the motivation introducing this namespace population mechanism. So to explain that in a short way is basically we are introducing a controller and another custom resource definition called namespace template. The controller is watching the namespace template and also the namespace creation. So every time when a namespace gets created, the controller will move on and extract the resources from namespace template and create them into the newly created namespace. So that's how it works. And this is more a detailed example of this namespace template. And an example, a complete creation flow is like the user creates a namespace using Kubernetes create namespace command. And basically, the controller watches the creation of namespace and extracts the objects into namespace template and create all these objects into the namespace. And there's a very important part in this flow is about the author who creates the namespace. Why that is important? Because it's a very common case. The namespace creator will not have additional permission in the class scope, especially in the multi-tenancy case. Otherwise, the namespace owner will be able to override all kinds of things the class admin manages. So usually they don't have permission beyond namespace. So while they create namespace, we need a RBAC rule to grant the namespace admin permission to the creator. And after that, the creator can add more users into the namespace or defining further RBAC rules. So the problem with a controller in the Kubernetes, when it watches the namespace creation, it has no knowledge about who creates the namespace. And it will be impossible for the controller to create an RBAC rule, granting the user, the creator, the right privilege. So in this flow, we have to leverage a mutating admission webhook. When it intercepts the creation of namespace, it will basically add a label to represent the creator of the namespace by passing in the username as a value of the label. Then when the controller watches the creation of namespace, it will have the idea who creates the namespace. And go back to this namespace template example, we can see there's a role binding here with some variable called creator, which will be substituted by the value from the label. And with that, once the role binding has been populated into namespace, the creator will have the right permission to manipulate further things into namespace. And also regarding another problem in this proposal is basically we have no idea when all the policy objects have been populated into the namespace. So there's alpha feature in current Kubernetes called initializers. We can leverage that today. That basically works by defining a initializer configuration with the namespace template controller. So when a namespace gets created, the initializer pending list will be populated with the namespace template controller. And when all the objects gets created into namespace, the controller will remove the name from the initializer pending list. And eventually the initializers automation controller will be aware the namespace is ready and then allow the client to move forward. However, this mechanism is going to be deprecated because there's no other use case today using this feature. So I'm actually proposing another KEP to keep this feature specifically for namespace. And at least we can have a mechanism to know whether all objects have been populated in the namespace or not. Let's skip the namespace matching. That's currently we don't use this mechanism. And these a few features I'd like to skip. These are more complicated features, and we don't need these at the beginning. So let's skip these. Something worth to mention is about the schema validation. Because namespace template is a CRD, currently we don't have a full mechanism to validate if everything is correct in the namespace. However, if there's anything wrong in the template, it will only be detected when we are trying to create these objects into a namespace at a very late time. So there's no better way to do that. We will only see something like the namespace population failure from the events or from the logs. This is we do today for this is what we propose for the MVP scope. And if we can find some better ways, we can do that later. Opt-out is also another complicated feature we don't want to do at the beginning. And mention namespace initialization, that will be moved to a separate KEP. And these are, I think these are all about the namespace population KEP. And if we go back to the secure profile, the last thing I want to mention about the customize and extension. As we define a few standard security profiles, the customer still have the possibility to customize a security profile. The way to do it is very simple. They just copy an existing security profile and rename it, and then update the rules inside and populate that into the cluster. Then update the security profile selector to select their own security profile. And that gives the possibility cluster admin is able to customize a standard rule, especially for their own business needs. So versioning and upgrade and deprecation, this is another session we can discuss if we have official repo about secure profile and we start development on that. But I will skip this for today. One more thing about the working with config as code systems. These systems basically manage all the Kubernetes manifest files in source control repo. And they will have CI/CD to vet all these changes before they push that into a Kubernetes system. So in that case, they definitely don't want some automatic mechanism to populate objects into the Kubernetes, because they want everything to be explicit and managed in the source repo. So in that case, we can turn off the namespace population mechanism in the security profile, but provide something like a CLI tool to be integrated into a CI/CD pipeline and help to do some static analysis of all the manifest in the current code repo, and basically check every changes to make sure they comply with the current selected security profile. So that's all I have today. I'm not sure if you have any questions.
So Yisui, again, this is lots of really good stuff. So before we get into some details, one quick question was, what was the status of the KEPs? Like, have you, I seem to recall that the technical committees have not yet approved these to go ahead, or sort of what was done in terms of getting these reviewed, and what was the response so far?
So things are still moving slowly, but get a little progress. So as I mentioned, the security profile KP is a very big umbrella which contains a lot of things, and this is definitely not good for a KEP to iterate on. So this is also the feedback I get from the community. So I'm trying to break out things. So the namespace population has been moved out. While as I just mentioned, the namespace population has another problem which requires the namespace initializer mechanism. So currently I'm working on the namespace initializer KEP. I can share with you.
So to be more specific, who did you take this to? Like, which committee sort of looked at this, and what did they have a documented set of feedback?
Yes. So this is definitely in the area of SIG-API Machinery team. And I have presented this namespace initializers KEP in SIG-API Machinery meetings twice. And actually, we have agreed to move forward by pinning every reviewer in about this KEP individually. So I'm going to send email to individual reviewers for explicitly comments from about this KEP. If they agree on this, probably the first move will be implementation of the namespace initializers to get upstream. And then we can move forward with other KEPs like namespace population and then further security profile. Let me try to open this. Where's the KEP repo? Yeah, so that's the current status. The namespace initializer is still being reviewed, but I think we can get agreement maybe in a few months.
So I think some thoughts I have is that obviously, as I mentioned to you, Yisui, you've done lots of really good work, and so we want to figure out how we as a working group can develop a position around this, as well as I think basically we need to, I think, develop first a slightly higher level model, because did you get the sense that the reviewing committee saw all of this in the context of a, had the correct big picture in terms of multi-tenancy operational model, or was this sort of as jumping into more detailed and not having the big picture on exactly what multi-tenancy model we are proposing here? Or it would be good to see their specific feedback.
Yeah, so definitely because the KEP are split up, so for each KEP, basically focusing on a specific area and basically a lot of details. It's definitely not about a bigger picture of multitenancy or skill profile. So I don't know if there's a better way we can move on. Like, for example, if we can rescope the skill profile KEP to have like short-term scope and quickly get that KEP proved, and then we can iterate on. So I think that's also the idea of the KEP process. That doesn't require a lot of details, but a very clear scope, and that can be quickly approved and quickly iterate on. So probably that's another way we may go.
Yeah, I think, and I welcome everybody else's comments as well. My initial thought is that maybe we create a clearly defined operational model for how, what this group is seeing in terms of, I mean, you've sort of embedded all of that through your, bootstrapping profile and all that, but maybe it needs to be coming out very clearly. And then one very, very simple model, which requires no new CRDs, no new objects. And we just get that one embedded into the Kubernetes conformance process so that we sort of have a win without creating new CRDs. And then that we build on that with how motivating how the new CRDs will additionally add value. I mean, just initial high level thoughts. Maybe I'll let others comment. And so that's my initial thought on how we can sort of build on this and also create a structure for going forward. But maybe others have some thoughts.
Yeah, I think that's definitely a very good, reasonable way to go. So basically, we start from test. Means we don't change any mechanism today. We don't have any implementation, but we can have a test that may fail at the beginning, and with the test, we can eventually adding the features to make sure the test gets passed someday. Is that correct?
Yeah, what I was saying was that even we could have a best practices guide, not just guide, but a reference configuration with or without the actual CRDs in place, and get that also tied into Kubernetes conformance testing so that we can then have a win with here's how you can do a conformance test on a Kubernetes cluster created today, right? Without any of these new CRDs.
Mm-hmm.
And, it gives you this model today. And we make that very clear as to what is the expectation in terms of cluster roles and admin roles and the level of isolation and all that. And that gives us a win with existing objects and is passing the Kubernetes conformance, right? We iron out any gotchas there. And then in parallel, we see how these KPs, whether they're split, whether they need to be split up or whether they need to be modified. And those can then kind of add to that in parallel.
Yeah, that's definitely a great idea. I'd like to take one step back. So before we will be clear to write to define which test to write. Probably we will have to define maybe a very small scoped but a very clear definition of a scenario and what we want to achieve and what's the criteria in that scenario and what's the required configuration. And once we have that, I think we can have a clear set of test cases that we can figure out. And with those, we can turn the cases into a conformance suite and probably propose that into a conformance SIG meeting.
Right. Yeah, that's kind of something like what I was thinking. Tasha, David, anybody else with any thoughts, comments?
Yeah, I think that makes a lot of sense. this KEP is really well formed, and definitely, seems to be going in the path that we're interested in. And so now I think it's just, how do we sort of align from a, kind of, how do we kind of get this moving? And I think looking at the conformance suite is a really good approach.
And I think we need to understand the kind of what is expected in conformance, because there are some surprising rules that Yisui and I discovered when we started thinking about this in terms of conformance last time. Like RBAC can't be part of conformance and stuff like that. And so I think we need to somehow get an explanation of what conformance actually, what those end-to-end tests can include and what they can't include, so that we can, do this properly and not get surprised at the end. Because, yeah, that's all. Like, I think everybody has a high-level understanding of conformance. It's like you write a bunch of end-to-end tests and they're supposed to pass. But exactly what can and can't be in those end-to-end tests, there's some fairly obscure rules around that, which I don't remember, and which we should get clarification on before we, start doing what we've been talking about here. And I don't know the best way to get that clarification. Probably ask the conformance SIG, or give them a high-level idea of what we're trying to do and ask for high-level feedback to start with before we get too deep into it, so we can make sure what we're planning aligns with what conformance is actually supposed to do, if that makes any sense.
Yeah, that sounds really good. How about you and I take it as an action item to figure out how to have that conversation and kind of bring back what we learned to the group?
Yeah, that sounds good.
Okay. So let's see. Does anyone have anything else they'd like to go over in this meeting?
So I just wanted to mention that for my action item for the Jan 15 meeting, I was essentially planning to put together some similar profiles, similar to what Yisui has as a sample profiles, but then also kind of throw out some next steps, which included exactly what we've just discussed, which is conformance, a plan for aligning with conformance. So maybe we'll do some prep work and then try to create some structure around that on the Jan 15th call, and I'll put together some initial thoughts which we should all work together on.
Yeah, that sounds great. Okay, well, thank you everyone so much for joining, and we will see you all January 15th, if not before.